All right, today we will look at the Raspberry Pi operating systems. And let's start with the installations. Those who are here with me in this class in person, the screens in front, upper left corner is missing, but on the other two, the single monitor are fully showing your lecture notes, so you can follow that. Eventually, it'll come out. Sometimes it is on, sometimes off. Okay, this is a general idea of Raspberry Pi 5, Model 5. Actually, it's not Model 5B, Model 5. Those who have a Model 3, Model 4, Model 5, very similar, and to complete the work required by this class, still possible in any models, so you don't have to worry about it. As I said, I have the older versions available for you to use, Model 3. So if you come to the Mercy Manhattan campus, particularly to this class on Wednesday, you can get one, but you have to let me know early. That way I can bring the device for you. Okay. Actually, even Model 3 has 4 USB ports, Type 2, Type 3, and then Ethernet ports, and then 40 pins available, all GPIO 40 pins. They are the same, and wireless connections possible. The earlier versions, only wireless, Wi-Fi, but not Bluetooth. The new versions, Model 5, also now equipped with the Bluetooth. That is good. And then processors is a lot faster on the later versions. Earlier, not really fast, but our work does not require anything the speed. I do not evaluate your work based on the speed, but functionality is the only that I am ask you to learn. Functionality, so speed or efficiency may be improved if it is not right now, but later when it comes the better models, okay? And the outlets here, two HDMI outlets. I believe the first one here, there's a HDMI 1, and the second one is HDMI 2. And then there is a power lines. This is USB Type-C. I think this much that you need. Others, not in this class yet. So if we are thinking of Raspberry Pi Model 5, then there's a system on chips from Broadcom, BCM 2712, ARM chips, 64 bits, 2.4 gigahertz. It has also GPUs. And then RAM size, the recent versions of Raspberry Pi Model 5, 16 gigabytes. But if you pay about $150, the kit that I recommend you, then it is equipped 8 gigabytes RAM size. Storage is up to your SD card. When you purchase that Raspberry Pi kit, it has a SD card, 128 gigabytes, already formatted as a bootable systems. Operating systems are already there. so you don't have to worry about any additional. But for those who do not have that original USB card, then you need to build the bootable bootable SD card that can boot your Raspberry Pi when you turn on your Raspberry Pi at the very first time. Video outputs, power supplies also. The power supplies provides 5 volts, 5 amp. 5 amp may be okay, unless you use really heavy jobs that require more amps. But 5 amps usually okay with a couple of the sensors and the size of the Python programs that we have here. No problem at all. And camera interface, GPIO pins. GPIO pins is very, very important that we are using for this project. There are 40 GPIO pins and all others. Skip operating systems. There's a Debian-based Linux operating systems, but it is called Raspberry Pi OS. Formerly, it is called Raspbian. It sounds like something else, so they changed Raspberry Pi OS. So what you need to do is Raspberry Pi assemblies. It is trivial. Installations, usually pre-installed SD card if you purchased. But if you have a brand new SD card, then you have to build separately, independently. I have another slide to explain this, so you will follow that. So basic configuration, this. Starting with the welcome messages. Then you need to set the language and keyboard, time zone. Please carefully have this. So English, there's a US English for the language. Keyboard, US keyboard, not the UK keyboard. Raspberry Pi is invented and still manufactured by UK. Some manufactured by other countries cheap, but I do not recommend that. This year when I looked at the Raspberry Pis, I think most of them are UK manufactured. Then you need to set your username and password. For cybersecurity purpose, I want you to keep this securely. But if you make this very hard username and hard keyword, then you may be able to forget it very quickly. Even if it is not quickly, maybe 2 years later, if you want to, hey, I want to go back to my Raspberry Pi. You open it, then by that time, you do not know username, you do not remember the password. And also this Raspberry Pi, I don't think you are running this Raspberry Pi for the service, the publicly. Always it is disconnected if you do not use. So make it simple. There's my tip, at least during this semester. The username that I am using for your reference, simply Pi, because it's a Raspberry Pi, right? All small Pi. And then password, in my case, Mercy, all small. That way you and I can help each other. Network settings. Okay, at your home you can. Oh, okay. This is. Oh yeah, so Wi-Fi connections. Your home you can choose yours, but here at Mercy, You need to let's see. How can I show you? What I'm, because I already set up the PNC, I'll let you know. Okay, here's the PNC viewer. I set up this morning here, MT25 Spring, February 12. If you set it up, then you can see this is actually the Raspberry Pi that you can see. And my host IP is 192.168.7.8. Okay, so the way you set up this PNC, if you go here, oh, why this guy? Okay, I'll disconnect that and I'll show one more. Here, properties. So what you need to do is the PNC server. You can get IP that's temporarily assigned to your Raspberry Pi from your router in this lab. Now it's ready to. So our router here, you can check your. Let me push this aside and then I will see if I can get that. Yeah, I can get that. So that I can get here. Host name, this is a Raspberry Pi, and space minus uppercase I, then you can get your IP address. This is a Raspberry Pi. This is my laptop. So I open up my PNC and I enter this and you name it and you activate this, then you connect. So my connection is like this. Okay. So in order to this, thing is this. Same router needs to be connected between your Raspberry Pi and your laptop. If this is a Raspberry Pi, if you see this, then there is the SSID code. Okay, SSID code is MT-CIS lab-Wi-Fi, right? So choose this. That is this. And at the same time, your laptop, you need to make sure that you need to choose MT-CIS lab Wi-Fi. So same router receives the signals from both your laptop and your Raspberry Pi. And then your router provides you loopback IP services so that you can connect. Okay, web browser is also possible. Software needs to be updated and upgraded. So update is to update the software repositories that is known by your Raspberry Pi. Once it is updated, then you can, if you have enough time, then you can do upgrade. Upgrade takes a lot longer time than updates. It takes about usually 10 minutes, 20 minutes, 30 minutes. Depends on the version update states of your Raspberry Pi. If you don't update and upgrade often, then upgrade takes a longer time. And then you can restart, then you will have your Raspberry Pi OS. Raspberry Pi OS, yeah. Okay, this is the GPIO pins. Raspberry Pi has 40 pins available, and it names from upper left to the lower right corner, 1, 2, 3. Each column, left column is in odd number, right column even number. I'm talking about these numbers. Okay. All of this number system here is based on board pin numbers. This is for board. Don't be confused with another label here. This guy and this guy. They are two different things. This is when you choose PCM mode, then you need to, on your codings, you have to follow this mode. Okay? We can practice both this board settings and PCM settings. Particularly if you want to work on PCM mode, then you need to have this the card that comes with your kit. You have to keep that all the time. If you are following board mode, then not necessarily from 0 to 1. But make sure here the pin number 0 and pin number 1, pin number 1 and pin number 2. This is a power line. So 5 volts from pin number 2 and 3.3 volts from pin number 1. And all others regular pins, except somewhere here in board number 17, that is the 3 voltages. I'm not sure this is for board matter or doesn't matter. I think it matters. So don't use 17 if you use board. All right. Here again ground from 20. So don't try to use 20 or 17, even if you work on board. But if you work on PCM, definitely you need to follow that. And also, depending upon the device that you connect, some devices use MSI, MISO, CLK. Some of this you may know later if you do not know now, because you don't need it actually. Some of you probably heard of UART. This is for transmission, this is for receiver. I think your cell phone's antenna is in this way, UART, TX and RX. So GPIO's two pin type, pin mode, board mode, and PCM. Board or PCM. Specifications, voltage levels, all others. Protocols, I2C, SPI, UART. For your, if you want to use the GPIO pins to connect, for example, sensor, then you need to turn on the SPI. Back here. If you go to preference and Raspberry Pi configuration, there's a tabs, but click on the interfaces. SSI for your BNC connections, you need to turn this BNC. So it is a turn on. And SSI a chip that if you want to communicate, if you want to jump into other servers, for example, from your Raspberry Pi to your MacBook, or vice versa, then you need to turn this on, SSH. Okay. Do you want to see that? For Mac users, this is not going to work for the Windows users. Here, if you want to go to my MacBook Pi then I need to use that 192.168.7.8. Remember, that is my Raspberry Pi, right? And then this is my username, PI. Then I can say yes at the very first time. And then he asks me to enter. So Mercy, I enter Mercy, then I have this Raspberry Pi. This terminal, actually the terminal of my Apple terminal, MacBook terminals. But from there, I now come into Raspberry Pi terminals. This is similar to the terminal that I have when I open this. Oh, I already had that, right? So that is the same as this. Let's see. Yeah. All right. So I forgot to explain. SPI needs to be turned on from your settings, preference, Raspberry Pi, interface. Then this SPI needs to be turned on, okay? SPI. This is a serial port interface. So it is the communication from your pin to your Raspberry Pi. Okay, whatever the sensor signals can coming into your Raspberry Pi, only if you turn on this SPI button. Okay, already done. So when you turn this on, then click OK buttons, then it works. Okay. And some of the interface that I explained here. What is an inter-integrated circuit? You probably hear some of this, I2C connections. If you do this I2C connection, then you need to use SDA GPIO 2 and 3 from the PCM mode. This is all PCM mode. Let me go back to show. Here, I2C, it says I2C, right? That's what I am saying here. That is I2C. I2C means inter-integrated circuits. Some of the device that you want to connect to your Raspberry Pi, then it says, hey, you have to connect this guy to not only to Raspberry Pi, but any communications, any connections with the external devices, then I2C. Okay. On the other hand, there is a SPI, serial peripheral interface. Our sensor usually uses this SPI. So if you're using this SPI connections and also PCM mode, then because this is high speed and full duplex protocols, that we use this kind of protocols. So GPIO 11, that is the clock, and MOSI, there's a master out, slave in mode, or master in, slave out mode, MISO. CEO, chip enable 0, chip enable 1. If any device that you want to connect, that provides this protocol, then you need to go with this SPI, and then pins that you can see this as that's somewhere in pin SPI CE0, CE1, SCL, and MOSI, MOSO, CLK. These are the SPIO connections. Okay. And then lastly, there is a universal asynchronous receiver transmitter UART protocols. Then that is transmit and receive ports that we already looked at, right? Somewhere here, transmit and receiver, that they're all UART. Okay. If your SD card is brand new, or for some reason, if it is not bootable, then you need to follow this. The two ways that you can do. You need to use new out-of-box software, so-called noobs, but I do not recommend you go with this, at least for Raspberry Pi. I recommend this. This is a lot easier. Using the OS Imager. Okay, this is easier. In order to do that, you have to download the Raspberry Pi OS Imager from your laptop. This is working on laptop. Your laptop, there is a USB port. Let me show. Some USB port, if you purchase the kit, then there's a small device, USB device, that can accept your SD card. So you can plug your SD card on that USB, small ones, like your thumbnails, small ones. You can plug in your the laptop USB port. Okay, so by running this PI OS Imager, by running this, you need to make your SD card bootable. Okay, so and if your SD card is still dirty means it is written already, then you need to reformat it. There's a program, sdcard.org. You can download it from, this is for free. There's a Mac version and Windows version, both are available. So you can reformat your SD card. Once your SD card is cleaned, then you need to start this Imager program that you already downloaded, right? This is the Imager program. Then you can see this is the first the window that you see. So you need to set Raspberry Pi OS. I think yours is 64 bits. Choose operating systems, and then choose the device SD card. You need to choose a specific USB port, and then click on this right. Then it goes. Okay, it's very, very quickly. It is very easy. Once you have that OS running on your Raspberry Pi, then you need to use keyboard, mouse, and monitor separately. If you want to connect your Raspberry Pi into your laptop, just like I am doing, then you need to set up VNC. So this is a VNC connections. This is something that you have to understand, the infrastructure. So you have your Raspberry Pi here, your laptop. Both are served by the same router. This router needs to serve loopback IP services. Okay, so on your laptop, open up VNC Viewer. As I showed, you need to put IP address. Then first some of the credential checks. So username and password. Before you do this, of course, on your Raspberry Pi, you need to Raspberry Pi configurations. So VNC needs to be enabled. Okay. So something missing to interface options. I don't know. VNC should go to VNC and enabled. This is, we already saw this. This is VNC. VNC needs to be turned on like this, and then reboot the system. Then you may be able to see. At the very first time, it says VNC Viewer has no record of connecting to this VNC server, so I ask you to do this. Are you sure you want to do? Click on this, continue. Only one time. From next time, then you can get that done. Okay, this is the introduction of the Raspberry Pi. Any questions? Have you tried this at home? Not yet?
No. I've done like some research into when I wrote up my proposal, I looked up like what hardware I need. And yeah, that was one of my main questions, like how do I connect to the Raspberry Pi to write the software? Yeah, that kind of answers it. But yeah, I had some confusion regarding, and I don't know if this is relevant to the current lecture, but
go ahead.
Regarding the connectors, like male and female, and then also the resistor.
Mm-hmm.
It's been a while since I worked with all this, so like yeah, so I'm like just learning.
What kind of a sensor do you use?
I want to do a magnetic sensor. Very
magnetic.
Simple.
Does it require resistance?
Based on my research, it's
yeah. If it asks you to use the resistance, you need to use.
Yeah.
Resistance is a color coded, so you have to learn what is how much it resists if there is any surge current coming in or going out.
Yeah.
So better to use, but I don't often use.
Yeah.
But only I use if it is required. If it is required, definitely you need to use the resistance.
It's probably on the vendor of the sensor. They'll tell you, right? Probably, yeah. So yeah,
I'm going to show to you some the wide sensor connections right now today. So you guys are lucky if you are here with me, but those who are viewing my recordings may not be directly understandable. So let me close this and I will move to the next module. Okay, so I'm going to explain this first and then my demo. Okay. Oops, this is not yet set. Slideshow. Yes.
Is the Zoom link still available for the online class? Zoom link? So, 'cause-
No, I didn't make. So
Yeah, because my friend is trying to get into Zoom, but he can't.
the reason for that is Zoom cannot see the same thing that we see here.
Well, I mean the.
Therefore, I don't. If they receive this lecture from Zoom, then remember that I show here something.
Don't you post it on Blackboard?
This is a recording being recorded, so later it'll be posted so that you can come back, but not simultaneously. Main reason is that Zoom viewer may not see the same one that we can see here, but I'm trying to show everything on my camera, my recording. So who is waiting? Somebody is waiting. But anyway,
Yeah, the person who
Person?
is going to have our road test. I heard he already told you.
yeah, you were with me last week. You're the only one that I had in this semester so far. Let's try to see this. Only what I'm worrying about, if I recording here and also Zoom and also communicate with my sensors overloaded. I had one bad experience. Everything went wrong. Yeah. So restart. We lose my recordings, everything. So I try not to. Let's see. It depends on. Is this class? Let me try.
So if you click the Zoom link.
Yeah. Let me try if he can join. So I schedule. This is 12. I'll put here. So share and start. So ask him if he can join. Okay. This is a data collections. So we have Raspberry Pi. Make sure that you have SPI communication enabled. I already explained that, right? Here's the things. Fact one, all GPIO pins in Raspberry Pi are for digital connections, digital signals. You need to keep that in mind. What does that mean to you? Some, if not all, of course it's not all. Some sensors has analog signals. It does not have digital signals. Particularly if we are working on some medical sensors usually doing analog signals. Some simple sensors handles digital signals. Very, very sophisticated and real-world sensors are doing digital signals. Okay. GPIO for Raspberry Pi does not provide digital signals. In such case, how can you do? I'll show it to you. So a lot of a burden in this case because of this. But if you're for this class project, when you choose your sensor, make sure that is a digital signals. If it is analog, I know you have some ambitions, like me. Medical sensors, then there is analog, then a lot more work involved. On my demo, maybe today, then we will go for that also. another fact number 2. Some sensors send, I already explained this, analog signals, right? For example, heartbeat sensors. This is particular that I am working on and give you a demo. This guy generates analog signals only. Then how can you get it? How to do? There's 2 ways that you need to do. To cope with the analog signals, then you need to buy another chip, ADC chip, analog to digital converter, from analog to digital. Then you can use this chip onto your Raspberry Pi, and on the other side, the other end, then you can use the analog sensors. So you can use SPI connections or I2C connections. Remember that we looked at this. This is some of the recommendation that you can buy, but I don't ask you to work on analog signals, but I am teaching you. There is an analog signal based sensors available. So don't say that, oh, I know all sensors. I know I can do that on Raspberry Pi. If you say that, then you know only 50%, right? Many sensors handles analog signals, and Raspberry Pi doesn't do that. Then you need to have another components. You need to have one separate converter chips like this, or Arduino Uno can bridge it. Today I will show to you this Arduino Uno. Okay, Arduino Uno is, this is Arduino Uno. Have you heard of Arduino in your life? No? Arduino, right? Arduino is Italian products. Raspberry Pi is UK products. We used the Arduino Uno very actively till 10 years ago, but only the problem with the Arduino Uno is not really problem. We can do another way, but the language provided by default on Arduino Uno is C language. Our university students do not learn C. So in order to use this, then I need to teach C, and then students has some difficulties. So I stopped using this, but rather we migrated to the Raspberry Pi. But right now, because the Raspberry Pi does not handle analog signal, but Arduino Uno. So Arduino Uno receives analog signals and then push the signal into the Raspberry Pi, and then all Raspberry Pi can handle. Okay. Sensors. So once again, we have a GPIO pin configuration like this. This layout needs to be, you don't need to memorize this, but you have to report to this all the time. Any number in green background, they are board number. Anything outside, there's a PCM GPIO. So again, enable SPI. Okay. This lab, sensor technologies, needs these 3 things in this way: wiring, scripting, and running. And one more, that'll be next week, uploading. Okay, sending the data to the cloud server. So wiring, scripting, and running. So wiring, for example, this is very simple ones, only LED, right? LED needs power and ground. That is provided by your GPIO. That is wiring. Once wiring, then you need to script. This is most important. You have to import RPI.GPIO. This, you can call this GPIO. This module needs to be imported. Therefore, your program can contact GPIO pins, and that GPIO pin may read some signals. The GPIO has a function called the set mode. So you need to use GPIO.PCM. There are two kinds, right? GPIO.PCM or GPIO.board. And then you can set up. This is a pin number. Pin number 21 that I want to use according to BCM. Then according to BCM pin number 21, then that is this, right? This is GPIO 21. And then this is our coding. I equals 0 while I is less than 20. We have to push this indentations. And then GPIO to this pin, GPIO 21, I want to do true signals. And then sleep 1 second. Sleep function from time module takes number. That number is in second. So 1 second sleep. What that means is that I turn on, I provide the power to this pin number 21, where there is a, I think LED light available. Pin number 21, therefore pin number 21 has a long leg of LED goes into that pin 21, and then provide the power. And for how long? 1 second. After that, cut it off. No power, so it is off. For how long? 1 second. We keep doing this. Okay, that is BCM mode. On the other hand, yeah, this is. So from GPIO, long leg here, connect to GPIO 21, short leg, go. We use here resistance. If your resistance is use big number, then it doesn't resist effectively. If it is too sensitive and very low number, then it is so sensitive to affect your LED communication. But right now, LED turn on and off. You don't really, if you do not know resistance, you don't need to use. If LED is burned, that's okay, because LED is so cheap. You can use another LED if you want, right? But in real theory, then you need to set up the resistance. Therefore, you can protect the power stabilized in this circuit. So one leg power from GPIO 21 according to PCM, and short leg goes to ground. So from ground to this, there's a circuit is established. Along the way, along the line, along the circuit, there is a resistance. If there is any surge, power can be handled by this. But LED only, here the high power is 5 volts. So not much big issue. Okay, for the same ones, let's use GPIO board. I use number 21 also. Then physical number 21 is not here according to a PCM bottom here. But if you see the labels on that board with the green background, then 21 that you can see very clearly. So you need to plug the long leg into that and run the same program. Then every seconds it turn on and off, on and off. For how long? In this case, for 20 times, right? You can set that. That's this. With that basic understanding, then you can use, for example, ultrasonic distance sensors. Ultrasonic distance HC SR04. Let's see if I have any. I have some of this. If you want, I can give it to you. Only I have 3 students. So this is a motion detections. So you can take one of those. Distance sensor, I have only one.
So I have to buy my own cable, right, to connect from here to the GPIO pin.
You need to have
Oh, okay.
the jumper cables.
Yep.
That has male, right? Your the GPIO is a male pins. It is a male pin or a female pins. So if you have a male,
Male.
it's a male pins, right?
Oh,
Let me see. See here back end. There's a male pins.
Oh, I see.
Should I explain male and female? In
I just
another
haven't
way?
worked with hardware like this before, so yeah. I mean, if I
You can just imagine. This is male.
yeah, I can.
Female
look it up.
is this is a female.
I see. Yeah. Okay.
So who needs?
What is that?
This is distance.
Yeah.
Right. Yeah. You can take some of this jumper cables. This is for male to male. Therefore, this guy has female and female. So one end put
Yeah.
there, the other end to Raspberry Pi. Not take all, but few of those. You can
Can I do two?
split. Yeah,
This
maybe
one? You
like
only need
this.
Two, right?
Huh?
You only need 2 for the sensor.
Depending on the pin.
Oh.
I think it has 3 pins, right?
Yeah.
So you need the 3.
Thank you. Oh, you gave me more than 3 here.
I take it.
Oh, thank you.
Don't need it. So I explained this physics behind this the distance sensor. So I want to skip this. Only, yeah, this I already explained that. Roden, I think you have this, right? Distance sensor
Yeah.
with you. So it has 4 pins. right?
Yeah.
4 pins. So at one end there is a voltage, the other end the ground. This guy asks you to use resistance, but you don't need to resistance if you do not have. Let's see if I have some resistance. Oh, I have here more for distance. Another type. Okay, here, Nam and Donggu. This is the same as that ones, but different types. See here, a trigger and receivers. This is distance sensor.
Okay.
But I think it needs this kind of.
It looks like male still, right?
So use
Male, female still.
use some of this. Take 2 of each. The type that you have to find out proper type. This from Sharp. Because that pin, oh, why only 3? I'm not sure. But different mechanism. Maybe you need to study.
Yeah.
I didn't. That's available right now. So you wire like this, and then, as I said here, this is a voltages. Usually, if you have enough jumper cables, then the red jumper cable usually for the power, black for ground, like here. This is the voltage, the black that is ground. In the middle, so one trigger, the other one echo. Then you can use some other colors. Echo goes there like this. That is connected like this.
I'm guessing, would it tell you on the, like, would it tell you on it which one is the positive, which one is the negative?
I think it says there. There's some indicator. Show it to me. There's a plus sign, minus sign. That is that, and in the middle maybe it's a trigger, echo, or yeah. Without it, impossible to use it. Okay, don't guess. You need to make sure that you know there's a signals, proper signals comes. This is the code. This guy used a board mode. Remember the module to import, same ones, and all according to that physics behind it, explained the last week, coded here. I'll say here, this is a set of the pins, trigger pins, echo pins, trigger even out, low, and high, low. Yeah, high is that you can send the signals. Low means you stop the signals. And then you check the time. This is start time and end time. You subtract that. Then you use pulse duration. Once you know how long does it take that round trip, then you can use this formula, okay? Then you can get the distance. Another motion detections. This is so one pin ground, the other one voltages in the middle that you can use these signals. Depending upon some signals, then you know there is a motions, unless otherwise no motions. So it looks like this. Signals here on orange. So it goes to pin number 11, and then ground on black goes to that black, pin number 3, and then power. This is power lines, pin number 2, and then this is extra LED, turn and off. If there is some motion detected, this guy wants to turn on or off, right? This is an extra. But instead of this, in your case, you can get the signal. For example, on this homework assignments, the very next homework assignments is that you need to set up with the one sensor, and you need to show what data that you acquire from that sensor. This is a code. Again, 2 modules imported, and then use board mode, and the 1 pin number 11. Remember that this guy needs only the other power, the 2 pins for power and ground. The 1 pin in the middle, that is pins for sensing. So that is 11. Pin number 11 goes there. Set up that pins. And then that 11, we get the signal I. If I is 0, then no, you can mention. If there is input from the sensor, from this sensor signals, if it returns nothing, then no intruder. If it returns 1, then you can say intruder detected. Okay, that is a sensor motion detections. IR temperatures. This is for IR. This kind of a temperature sensors. I think it needs 4 pins. Power and ground, and then there is 2 pins to read, SDA and SCL. So I use the power pin 2, ground pin 2, the GPIO pin number 6. SDA pin goes to GPIO pin number 3. SCL goes to GPIO pin number 4. That's a GPIO ones. And in this case, this is a manufacturer sensitive the products, so you need to download from that manufacturer. MLX 9614, you need to import to that. This guy has you set up the sensor and then get the temperatures, ambient temperature, so surrounding temperature. This is object temperature. So you can get 2 different temperatures from here. Okay. So this is a IR temperature. Therefore, it's actively emit the infrared signals to outside. Some signals may be reflected from objects, then that is object temperature. Some may be surrounding, ambient temperature, then it comes, that is the temperature for ambient. The other one is Adafruit DHS sensor. If you go to this Adafruit companies, this is company website, then you can see there's three models: DHT11, DHT22, DHT2302. The one that I set up and give you a demo today, that is, this is a DHT sensor, which means humidity and temperature sensor together. But 11, type 11, which means less expensive. So download the package from GitHub that I downloaded. What I want to show, I want to shut down the current. This one is shut down. Okay, so this is DHT11, and my Raspberry Pi is currently running. I'm starting up and see. Okay, I need to set up my, oh. Mouse is not running. Why? Where is the mouse? I'll switch the mouse because it is not running. Still not. need to restart the system. Okay, now mouse is working. I need to set up the network. Oh, I have to set up so many things. What I want to do is I want to stop recording because